Okay, so we have here a Zener, okay, and this Zener is actually connected to a battery, and this battery has a voltage of -2, okay? So it's better always to flip the battery and see, you know, uh, its connection to the diode while it has a positive voltage. So let's flip this. So we'll draw just the same circuit, exactly the same circuit. But this battery will be flipped like this. Okay, we have here R2, we have here R1, and we have 2 volt. Okay, so this battery here is connected actually forward to the diode because the positive terminal of the battery is close to the B. The negative terminal of the battery is close to the N. Okay, or you can say this battery wanna push current from B to N because the current flows from the battery will go like this and branch it like this. So it's when it's branched in the diode branch or the Zener branch, it would flow from B to N. It's forward, but probably it's on as well, or off, but it's forward at least. So this diode, this Zener, is forward biased. But we don't know for sure if it's on or off. Okay? Okay. Good. So we have two ways. Either, assume something, assume it's on, for example, solve the circuit C, or find the minimum input that will turn this diode on in forward bias, and compare the value of 2 to this V input minimum. Okay, so we can do both actually. Okay, so let's do it by the V input minimum stuff. Remember, in that particular example, we have solved it in our lecture, but we solve it when the battery has this terminal, has polarity, but the value is positive. So the V input minimum that we solved or found in that lecture was actually the V input minimum that will turn the diode or the Zener on in its reverse or breakdown, not the V input minimum that will turn it into on when it's forward. Okay, so you should differentiate between these two situations. So you shouldn't mix. So you have two V input minimum here. You have V input minimum reverse that will turn the diode or the Zener into the breakdown on, but in reverse. And you have another V input minimum that will turn the diode on in forward. So this is the one, okay, the V input minimum that will turn the diode on in forward. So let's find this. So let's find the input minimum to turn the Zener on in forward, which is our case now. So let's draw the circuit now with this. Oh, sorry, it's very bad drawing. So this is the input minimum right now. And remember, this V input minimum is positive, and it's connected forward to the Zener. Okay? This will turn the Zener into on, just on, in forward. So at that moment, or at that input settings, VD is equal to 0.7. So in that way, 0.7. But ID is equal to 0. And ID flowing from B to N is equal to 0. Okay, so this is R1, this is R2, and R2, I think it's half a kilo ohms, R1 is 1 kilo ohm. So basically, since ID is equal to 0, it's like open circuit, we can say. Okay, so VR2 in that direction is equal to Vn minimum, multiplied by R2 over R1 plus R2 equal to Vn minimum, which we don't know, multiplied by R2, which is half a kilo ohm. Half a kilo ohm plus 1 kilo ohm, it's actually 1 over 3, we can say, right? Yes, 1 over 3. This is half over 1.5, so just 1/3. So Vn minimum is equal to 3 VR2. But what is VR2? If you look here, VR2 is just in parallel with the diode. So VR2 is actually equal to 0.7 in that case. So 2.1 volt. This is the input minimum. So we need at least 2.1 volt to turn this diode on and forward. So now let's look back at what's the value we have. We have 2. So since V input now equal to 2 less than Vn minimum, so the Zener, yes, it's forward, but off. So basically, I Zener, which is ID, is equal to 0. Okay? So it's like open circuit, as we said. So basically, the voltage VR2, again, is equal to V input, R2 over R1 plus R2, equal to 2, multiplied by R2 half over 1 half. So half 2 multiplied by 1/3, it's around, yeah, 0.667. So less than 0.7. So it's really off. We are right. Yes, it's forward because the voltage is positive, but less than 0.7, so it's off. And this is VR2, and VR2 is actually equal to VD. Just look here. So they are parallel. And VD is in that direction here. This is VD. So VD is equal to 0.667, less than 0.7. The diode is really off. Just a check, because you know what is the input minimum that will turn the Zener on and forward. Let's do it another way, another solution. Okay, so let's go down here. So let's take a line like this. Let's draw again the circuit. This is R, I don't know, R2. It's R1. Our Zener here. Again, yeah, our Zener is like this. And R2 here. And we have battery like this, which is -2. Okay. Again, so this is another solution. Again, it's better to flip the battery to know what exactly you are dealing with. R2, Mr. Zener, R1, and the battery, 2 volt. So the battery is connected forward. So positive with B, negative with N, or again, this is pushing current in that way, the diode from B to N, so it's forward. So this is forward biased. So the diode, the Zener diode, is forward biased. But we don't know for sure it's on or off. Let's assume it's on, that's fine. Assume it's on, assume on. Assume it's on, so VD is equal to 0.7. So we have here 0.7. And the ID should be positive, larger than 0. Okay, good. So this is ground here. So this is larger than this by 0.7. So this is minus 0.7. This one here minus 0.7 because B larger or greater than N by 0.7. This is 0, so this is minus 0.7. Okay, so let's assume here a current called the I1, another current here called the I2. Or the opposite. Let's assume the opposite way, yeah, because not to have negatives and this, bad stuff. So let's assume the opposite way. This way, because the battery will push current in that way. So this is I2, this is I1, and here we have ID. Okay, so I1 is equal to this point minus 0.7 minus this point. This is 0, this is 2, so this is minus 2. Over R1, which is which is 1 kilo ohm, right? Yes, 1 kilo ohm. So minus 0.7 plus 2 over 1 kilo ohm. So I1 equal to 1.3 milliamperes. Good. Now let's calculate I2. So I2 equal to this one, which is 0, minus this one, which is minus 0.7 over half. So half kilo ohms. So plus 0.7 over half kilo ohm. Half will be 2, so 1.4 milliamps. Okay. So we get I2 and I1. Now is the moment of truth. ID. So ID from here, this is I1 equal to ID plus I2. So ID is equal to I1 minus I2. I1 is 1.3 milliamperes. I2 is 1.4 milliamperes. So ID, unfortunately, is minus 1.1 milliamperes. Negative. So the assumption is incorrect. Okay? And we know that for sure because from the first solution, we know that it's off. Okay? So assume off. So ID is equal to 0. And we should find that VD is less than 0.7 this time. So ID is equal to 0. That means it's like open circuit. Okay. So we can, VR2 in that way. VR2 is equal to 2 multiplied by R2 over 1 plus R2. So 2 multiplied by R2 is half, 1.5. So this is 2 times 1/3, 2 over 3, 6, 6, 7, less than 0.7, because VR2 is just equal to VD. And when you have a diode forward but have a voltage less than 0.7, then the diode is really off. That's what was expected in the beginning. We know it's forward, so the voltage must be positive. But we assumed it's off. And this should be the correct solution because we proved that it's not on, so it must be off. So the diode must have a voltage less than 0.7. Okay, guys, I hope this is useful. I will publish this on Canvas and also the YouTube video. Thank you.